power supplies. In this review, you will learn how to select the correct power supply for a personal computer, PC, to support the main components of a PC. As you learned in a previous video, computer systems require direct current, DC, of electricity to operate. However, power companies deliver electricity in alternating currents, AC. AC power can damage the internal components of a computer. To solve this problem, computer power supplies are used to convert the AC from the wall socket to DC. Power supplies also reduce the voltage delivered to the computer's internal components. Computer architecture. Computer architecture refers to the engineering design of computers and the interconnecting hardware components that together create computing devices that meet functional, performance, and cost goals. Power supplies are part of the hardware layer of computer's architecture. We learned earlier about the other major hardware components of computer's architecture: motherboard, chipsets, CPUs, RAM, storage, peripherals, expansion slots, and cards, etc. These components influence the size and type of power supply a computer needs. Selecting a power supply. Local input voltage. A main consideration when selecting a computer power supply is the voltage delivered to common wall sockets in the country. Power standards for input voltages can vary from country to country. The most common voltage inputs are 110 to 120 VAC, 220 to 240 VAC. VAC stands for volts of alternating current. Voltages in the Americas North, Central, and parts of South America use the 110 to 127 VSC standard for common wall sockets. Computers and power supplies sold in these regions are designed to use this level of power. Voltages for most of the world. Most countries use the 220 to 240 VAC standard for common wall sockets. Computers and power supplies sold in these areas are designed to use this higher voltage. Please visit World Standards, plug, socket, and voltage by country to find your country's voltage standards. It is important to use the correct voltage power supply or power converter for the computer's voltage specifications. Imagine that you have a customer who imported a PC from a country that uses a different standard for input voltage. You will need to adapt the input power to protect the computer. Some options for doing this might include: replace the power supply with a unit that uses the appropriate voltage for the target country. Install a power supply model that includes a dual voltage switch that can be toggled from 110 to 120 volts amp to 220 to 240 volts. Plug the computer into an external power converter that then plugs into a normal wall socket. Power converters can be purchased from any store that sells international travel merchandise. Without a power converter, the following problems may be experienced. If a computer needs what the wall socket delivers, the result will be 220 to 240 volts, 110 to 120 volt, not enough power for the computer to run properly. 110 to 120 bus, 220 to 430, too much power, which will damage the computer's internal parts. Motherboard engineering specifications. The motherboard and form factor specifications document provide a list of compatible power supply types to help you select the correct part. The ATX form factor is the most common motherboard design for full-sized personal desktop computers. You may also find a version of the ITX form factor in smaller computers. The form factor size and components embedded in the motherboard will create a starting point for the minimum power supply wattage required. Power consumption of components. The number of internal components and peripherals the computer will need to support will also determine the minimum wattage power supply must provide. For example, a basic computer that is designed for word processing and surfing the internet should work with a standard power supply. However, some computers may need higher wattage power supplies to support items like powerful CPU, multiple CPUs, multiple hard drives, video rendering applications, a top-tier graphics processing unit, GPU for gaming, and more. Voltages and pin connectors. The internal hardware components of a computer require varied input voltages to operate. Voltage regulators embedded in the motherboard of the computer control the amount of power that is delivered to the computer's various internal components. Voltage. Examples of components that use each voltage level: 3.3 volts DIMMs, chipsets, and some PCI HDD cards, 5 volt SIMs, disk drive logic, ISAT, and some voltage regulators. 12 volts motors and voltage regulators with high outputs. The computer's power supply plugs into an adapter on the computer's motherboard. The wiring for this connection uses color-coded wires. Each wire color carries a different voltage of electricity to the motherboard, or serves as a grounding wire. A standard ATX motherboard power adapter has either 20 pins or 24 pins to connect these wires. The 20-pin design is an older technology. The 24-pin connector was developed to provide more power to support additional expansion cards, powerful CPUs, and more. The 24-pin connector has become the standard for today's personal computer power supplies and motherboards. The power supply will have multiple connectors that plug into the motherboard, hard drives, and graphic cards. Each cable has a specific purpose and delivers the appropriate amount of electricity to the following parts: connections from a PC power supply, ATX2, floppy disk drive, obsolete, Molex Universal, e.g. ID hard drives, optical drives, SATA drives, graphics cards, 8-pin, separable for 6-pin, graphics card 6-pin, motherboard, 8-pin, motherboard P4 connector, can be combined to 8-pin mainboard connector, 12 volts ATX2, 24-pin, divisible 20 plus 4, and can therefore also be used for old 20-pin connections. We will learn how to install a power supply and connect these power cables later in this module. Key takeaways. When selecting a power supply for a computer, the following items should be taken into consideration: wall socket input voltage standard for the country where the computer will be used, the number and power consumption needs of the computer's internal components, motherboard model and form factor engineering specifications and requirements. Resources for more information. For more information on these topics, please visit plug, socket, and voltage by country, list of countries around the world and their voltage standards for common wall sockets and plug types, how to diagnose and replace a failed PC power supply, step-by-step illustrated instructions on how to diagnose a power supply failure and replace it on a desktop PC.
Hi there, it's me again. You might remember me from the previous module, and no worries if not. What's important is that I'm here now. We made some updates to this program to make sure you got the latest info on mobile devices. You'll see me again throughout the rest of this program, so keep your eyes peeled for me. Let's talk about mobile devices. Mobile devices are computers too. They have CPUs, RAM, storage, power systems, and peripherals. How are they different from a server, a desktop computer, or a laptop? They're special because they're mobile. They're portable and usually powered by batteries. Some mobile devices are general-purpose computing devices, tablets, or smartphones. Other mobile devices are optimized to perform a specific set of tasks, like fitness monitors, ear ears, and smartwatches. Mobile devices are usually very integrated. Remember the systems that we showed you earlier? The components can be taken out and held in your hand. Mobile devices build some or all of these components together in a way that you can't take apart. The smaller the device, the more integrated the components usually are. CPU, RAM, and storage might be soldered directly to the device's motherboard. Very small mobile devices use a system on a chip, or SoC. A system on a chip packs the CPU, RAM, and sometimes even the storage into a single chip. Not only are SoCs small, they use less battery power than if those components were separated. Even though they're small, some mobile devices use peripherals. Smartphones connect to Bluetooth headphones, for example. Mobile devices can also be a peripheral. A fitness tracker is a standalone device, but it can also be a peripheral to your smartphone. That same fitness tracker might use a heart rate monitor as a peripheral. It's peripherals all the way down. Mobile devices may use standard or proprietary ports and connectors. You might need to have a specific adapter or connector for charging a device, or connecting your mobile device to a computer. Sometimes the physical shape or the intended use of the mobile device makes a standard connection like USB bad choice. For example, say you have a waterproof fitness tracker. If it had a micro USB port, that port would be damaged if exposed to water. So instead, it's designed with a custom charging interface that can be submerged under. Here's all the standard power, data, and display connector types you'll find used in mobile devices. This is a USB-C. Next, we have a Lightning adapter, then a mini USB, and a micro USB, a micro HDMI, and a mini HDMI, and this is a mini display. Because mobile devices are generally small and have limited access to power, they run operating systems and application software that's specifically designed to maximize their performance. We'll dive into mobile operating systems and applications in future videos. As an IT support specialist, you might be responsible for helping end users with their mobile devices. This might include setup, troubleshooting, repairing, and replacing mobile devices. Don't worry, we're going to break all this down for you. One super important thing, mobile devices can contain a lot of personal data. Some organizations allow people to use their own personal devices for work. We call this bring your own device or BYOD. You should be careful to respect people's privacy when they bring their own devices to you for help. To know how to handle these devices, it's always best to refer to your organization's policy.